Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
The Voyager 1 spacecraft, hurtling toward the edge of our solar system, has made a chilling discovery that could change the course of human history forever. As it ventures deeper into the unexplored regions of space, the probe has detected a mysterious signal, the origin of which remains unknown. But what makes this finding truly terrifying is the fact that Voyager 1 is heading back towards Earth, and this has left scientists on edge. What could Voyager 1 be intercepting that's so disturbing and mysterious? Join us as we unravel the secrets of the universe and explore the enigmatic message from Voyager 1. First, let's start with the launch of the twin probes. The Voyager program includes two interstellar probes named Voyager 1 and Voyager 2. In 1977, these probes were launched to explore the gas giants Jupiter and Saturn, as well as the ice giants Uranus and Neptune, to collect important data to send back to Earth. After the initial launch, Voyager 2 was redirected towards Uranus and Neptune to further gather data for transmission back to Earth. This launch may not have happened if certain events had not occurred. In this particular case, the aligning stars were the four largest planets in our solar system. These planets were gradually aligning in a manner that had not occurred. Unfortunately, this rare planetary alignment went mostly unnoticed. However, it was Gary Flandro, a doctoral student in aeronautics at the California Institute of Technology, who first recognized its significance. This recognition took place back in 1965, when space exploration was just beginning. Flandro, who was working part-time at NASA's Jet Propulsion Laboratory in Pasadena, California, was assigned the task of determining the most efficient way to send a space probe to Jupiter, or even further out to Saturn, Uranus, or Neptune. Using a simple pencil and his keen mathematical skills, Gary Flandro meticulously plotted the intricate orbital paths of the colossal planets, ultimately stumbling upon a groundbreaking discovery that would change the course of space exploration. It was during the late 1970s and early 1980s that a rare and wondrous event unfolded in our solar system, a celestial alignment of epic proportions where Jupiter, Saturn, Uranus, and Neptune all lined up in perfect harmony. This rare cosmic occurrence presented a once-in-a-lifetime opportunity for a spacecraft to embark on a grand tour of the outer planets, utilizing the gravitational assist of each planet to propel itself towards the next destination at unprecedented speeds. What could be found in this planetary body as they align closely? What unknown needs to be discovered? Scientists were so intrigued. However, Flandro's ingenious calculations unveiled the potential of this planetary alignment, showcasing the possibility of reducing the arduous journey from Earth to Neptune from a staggering 30 years to a mere 12 years. This cosmic phenomenon came with a significant catch. Such a perfect alignment only occurred once every 176 years. Seizing this extraordinary chance, NASA wasted no time in setting its sights on the stars, commencing the meticulous construction of two spacecraft Voyager 1 and Voyager 2, designed to capitalize on this rare celestial opportunity. Armed with cutting-edge technology and a sense of wonder, Voyager 1 and Voyager 2 set out on an unprecedented mission to explore the outer reaches of our solar system, their trajectory guided by the visionary calculations of Gary Flandro. These intrepid spacecraft were tasked with unraveling the mysteries of the distant planets, venturing into the unknown depths of space with the hopes of expanding humanity's understanding of the cosmos. The Voyager twin probes, Voyager 1 and Voyager 2, were launched on September 5, 1977, from Cape Canaveral in Florida. Voyager 1 initiated its groundbreaking journey into the unknown depths of space atop a Titan IIIe rocket, while Voyager 2 followed suit just 15 days later on August 20, 1977. Voyager 1 set out on an extraordinary cosmic expedition with the primary objective of delving into the mysteries of the gas giants Jupiter and Saturn, as well as their intriguing moons. These fearless space pioneers surpassed all preconceived notions, venturing beyond the limits of conventional exploration. They traversed vast distances and endured the test of time, surpassing all previous spacecraft in history and setting numerous records along their odyssey. Voyager 1 and Voyager 2 have boldly ventured into the uncharted expanse of interstellar space, a realm within our galaxy that remains largely unexplored. Despite being situated over 12 billion miles away from Earth, these trailblazing spacecraft continue to captivate and astound scientists with their groundbreaking discoveries and invaluable insights into the cosmos. NASA has implemented various ingenious tactics to guarantee their continued functionality. By deactivating non-essential elements like spare parts and heaters, they can save power effectively. This approach is designed to maintain the spacecraft's optimal performance until at least 2030. For the committed scientists and engineers who have been involved in this remarkable journey since its beginning, their dedication finally bore fruit. And just when they believed the Voyager missions were reaching their conclusion, a remarkable discovery surfaced from the vastness of outer space. Groundbreaking discoveries. Can you picture journeying through the galaxies, capturing and witnessing wonders of celestial bodies? During their epic expedition 4 decades ago, the Voyager spacecraft embarked on a remarkable journey that left scientists astounded. They ventured into the unknown, capturing the first-ever up-close glimpses of Jupiter and Saturn's moons. These celestial bodies, once believed to be monotonous and pockmarked like our own moon, turned out to be vibrant and captivating worlds. Voyager 1 reached Jupiter in March 1979, a mere 546 days after its launch, while Voyager 2 took a slightly different path and arrived in July of the same year. Both spacecraft were equipped with state-of-the-art VidCon cameras, equipped with special filters to capture stunning full-color images. Interestingly, these cameras were designed to maintain stability by spinning through space at a leisurely pace, more than 15 times slower than the hour hand of a clock. This deliberate motion ensured that the images they captured were crystal clear and razor-sharp. Throughout their mission, the Voyagers snapped an astonishing 33,000 photographs of Jupiter and its moons, each unveiling new and captivating details. For instance, Europa, one of Jupiter's 53 named moons, revealed a cracked, icy crust estimated to be over 60 meters thick. These discoveries were nothing short of awe-inspiring. As the spacecraft bid farewell to the Jupiter system, they received a tremendous boost in speed. A gravitational slingshot maneuver propelled them toward the vast expanse of interstellar space, propelling them forward at a mind-boggling speed of 35,700 miles per hour. This maneuver was crucial in their journey, propelling them further into the unknown. All of a sudden, Saturn was in view. As they ventured into the depths of Saturn, the two Voyagers embarked on divergent paths. Voyager 1 fearlessly navigated through the grandeur of Saturn's majestic rings, enduring countless collisions with minuscule particles of cosmic dust. It then soared past Titan, a moon enveloped in a captivating orange haze, and continued its northward odyssey, departing from the celestial plane where the planets reside. Meanwhile, Voyager 2 embarked on its solitary expedition, venturing further into the cosmos and eventually reaching the distant realms of Uranus and Neptune in the year 1986. During its exploration of Uranus, Voyager 2 made a remarkable discovery, unveiling the existence of 10 previously unknown moons. Additionally, it unveiled the presence of rings encircling the planet, thus expanding the list of worlds within our solar system adorned with these celestial adornments. However, amidst the triumphs of Voyager 2, a tragic event cast a somber shadow. Merely 4 days after its closest encounter with Uranus, the Space Shuttle Challenger experienced a devastating explosion shortly after liftoff. This heart-wrenching incident claimed the lives of all 7 courageous crew members, including Krista McAuliffe, a dedicated high school teacher from New Hampshire, who had been on the verge of becoming the first civilian to embark on a celestial voyage. 3 years later, Voyager 2 soared over Neptune's stunning azure methane sky, located about 2,800 miles above the planet's surface. It encountered the swiftest winds ever recorded in our solar system, clocking in at speeds of up to 1,000 miles per hour. Triton, Neptune's largest moon, turned out to be one of the chilliest spots in our cosmic vicinity, with temperatures plummeting to a bone-chilling -235 degrees C. The moon's icy volcanoes were yet another remarkable find, spewing nitrogen gas and fine particles up to 5 miles into its atmosphere. After Voyager 2's mesmerizing snapshots of Neptune and its moons, both spacecraft were scheduled to power down their cameras, marking the conclusion of their official mission. However, astronomer Carl Sagan, a member of the mission's imaging team, intervened and persuaded NASA to allow Voyager 1 to snap one final series of images. On Valentine's Day in 1990, the spacecraft turned its cameras back towards the inner solar system and captured 60 last shots. Among these images, famously dubbed the Pale Blue Dot by Carl Sagan, was a snapshot of Earth from a staggering distance of 3.8 billion miles. In the picture, Earth appears as a speck barely discernible against the vastness of space, illuminated by a faint glimmer of sunlight reflected off the camera's optics. The discoveries are not over yet. Beyond the heliosphere. In August in the year 2012, Voyager 1 achieved an extraordinary feat by venturing into uncharted territory beyond the heliosphere, a vast expanse filled with particles emitted by our mighty sun. This remarkable accomplishment garnered widespread acclaim the following year when a groundbreaking study detailing Voyager 1's momentous discovery was published in the esteemed Journal of Science. During the period spanning from April 9th to May 22nd in the year 2013, the spacecraft's plasma wave instrument detected a powerful solar eruption. This momentous event caused electrons in the vicinity of Voyager 1 to vibrate, indicating that the spacecraft had entered a region with a higher concentration of particles compared to the immediate surroundings of the heliosphere. At first glance, it may seem perplexing that the density of electrons is greater in the vast expanse of interstellar space than in the proximity of our radiant sun. However, diligent researchers elucidated that the electron density at the edge of the heliosphere is significantly lower than that found on the surface of our beloved Earth. On that fateful day of the discovery, which coincidentally marked the passing of the renowned astronaut Neil Armstrong, who had played a vital role in the historic Apollo 11 mission, Voyager 1 made an extraordinary revelation, uncovering a 1,000-fold reduction in solar particles and a 9% surge in galactic cosmic rays originating from beyond our solar system. These remarkable findings offer profound insights into the ever-changing and dynamic nature of our cosmic vicinity, showcasing the vastness and intricacy of space exploration. Voyager 1 accomplished an astounding distance of 11.25 billion miles from the Sun, which is approximately equivalent to 121 astronomical units. At this critical juncture, NASA's Planetary Science Division was diligently delving into the mysteries of the solar system through various methods such as flybys, orbiting, and sample return missions. The Voyager missions, acting as pioneers and architects of this approach, laid the foundation for future exploration endeavors. The Voyager spacecraft played a pivotal role in surveying the universe and shaping our research priorities. By conducting flybys, these missions significantly bolstered the success of planetary science. The concept of gravity assist, which involves utilizing the gravitational pull of a planet or another celestial object to alter the speed and trajectory of a spacecraft, proved to be indispensable for Voyager's triumphant exploration of the outer planets. Scientists and astronomers persist in their unwavering pursuit of unraveling the enigmas of the cosmos. The Deep Space Network, DSN. Have you ever wondered how messages are received from outer space, which is a million miles away? In the pursuit of interstellar exploration, the Voyager missions relied not only on the gravitational forces of celestial bodies, but also on a crucial component known as the Deep Space Network, DSN. This remarkable element can be likened to a celestial telephone line, connecting us with our intrepid Voyager probes as they ventured into uncharted territories. Although it may lack the allure of a spacecraft, the DSN plays an immensely vital role. Spanning the globe, this vast network consists of colossal radio antennas scattered across various locations, from California to Spain to Australia. These mammoth dishes, some as wide as 70 meters, act as cosmic megaphones, enabling us to establish communication with spacecraft that reside in the distant reaches of space. The Voyager probes play a crucial role in the missions by acting as our eyes and ears in the vastness of space. Fitted with cameras and sensors, they gathered valuable data and transmitted it back to Earth. To decode this data and guide the probes, a robust communication system was indispensable. This is where the Deep Space Network, DSN, stepped in. For instance, when Voyager 1 relayed a message from the outer edges of our solar system, the signal traveled at incredible speeds through space, but upon reaching Earth, it was barely discernible. Nonetheless, the DSN's massive antennas managed to capture this faint signal and convert it into meaningful information for scientists. The DSN's role extends beyond mere signal reception. It also dispatches commands to missions like Voyager. These missions are dynamic and often necessitate adjustments or instructions to be sent to the spacecraft. These commands are transmitted via the DSN, traversing space to reach Voyager. Essentially, it's akin to engaging in a two-way dialogue between Earth and these extraordinary man-made entities in space. The Deep Space Network, DSN, operates continuously, 24/7, and maintains a constant vigil for distant signals. It serves as more than just an array of antennas, rather it serves as our crucial link to the vastness of space. As the Voyager missions push further into uncharted territories of interstellar space, the DSN faithfully preserves the narratives of these remarkable endeavors. Throughout their extensive journeys, the Voyager probes have encountered numerous obstacles. Voyager 1 in particular boasts 3 onboard computers, one of which is a flight data system responsible for gathering information from the spacecraft's scientific instruments and merging it with engineering data. To ensure the well-being of Voyager 1, this data is transmitted to mission control on Earth in binary code, consisting of ones and zeros. However, a recent issue has arisen with Voyager 1's flight data system. What caused this issue and how does it affect us all? Voyager 1 encounter challenges in space. Voyager 1 seems to be trapped in a repetitive loop, continuously transmitting the same sequence of ones and zeros back to Earth. This anomaly was initially detected on November 14th, when the spacecraft's telecommunications unit began exhibiting erratic behavior. While Voyager 1 can still receive and execute commands from mission control, no fresh scientific or engineering data is being transmitted back to Earth. NASA engineers have endeavored to restart the flight data system, yet they have not yet received any usable data. Presently, they are diligently working to identify the root cause of the problem before determining the subsequent course of action to rectify it. This process may extend for several weeks, and it's fascinating to note that Voyager 1 encountered issues with its flight data system back in 1981. However, the current problem seems to be completely unrelated to any past glitches the spacecraft has faced in recent years. The mission team is relying on manuals written decades ago for guidance as Voyager probes face new obstacles. While these manuals are detailed, they couldn't have predicted all the challenges the spacecraft would encounter on its cosmic journey. The team is proceeding cautiously, carefully considering all potential implications before sending any further commands to Voyager 1 to ensure its operations remain unaffected. Voyager 1 is positioned so far away that it takes a whopping 22.5 hours for signals to reach the spacecraft from Earth. Additionally, it takes an extra 45 hours for the team to receive a response. As the Voyager twin continue their momentous odyssey through the vast expanse of space, the team has been confronted with difficult choices to sustain their progress. To conserve power and prolong the duration of their missions, certain instruments on these aging probes have been deactivated. These intrepid spacecraft have encountered unforeseen obstacles, such as 7 months in 2020, when Voyager 2 lost contact with Earth. However, through a fortunate turn of events, the team successfully restored communication in August by employing a clever technique that realigned the spacecraft's antenna. While the team remains optimistic about reinstating the regular flow of data from Voyager 1, the true significance of these missions lies in their remarkable longevity. Scientists eagerly anticipate the opportunity to examine how particles and magnetic fields evolve as the probes venture further away from the heliosphere. Nevertheless, This invaluable dataset will remain incomplete if Voyager 1 is unable to transmit information back to Earth. Despite the challenges, the team has demonstrated ingenuity in devising methods to extend the power supply for both spacecraft. The Voyager missions have far exceeded their initial expectations, surpassing the lifespan of any other spacecraft in history. Consequently, while the engineers tirelessly strive to sustain their operations, they are fully aware that additional obstacles may lie ahead. Despite their diminishing power, the voyages of these spacecraft are far from reaching their conclusion. Venturing into interstellar space, reaching the outermost regions of our solar system, is a more challenging task compared to venturing into interstellar space. The Oort cloud, a far-off assemblage of comet-like objects, remains in position due to the gravitational pull of the Sun. This cloud potentially extends halfway toward the nearest star, and it will take the Voyager probes roughly 300 additional years to reach its outermost edge. Interstellar space refers to the region beyond where the solar wind, a stream of charged particles and magnetic fields emitted by the Sun, ceases to exist. The solar wind acts akin to air inflating a balloon, creating a protective bubble known as the heliosphere that envelops the solar system and is carried by the solar wind. Eventually, this bubble encounters resistance from interstellar material, resulting in the establishment of a boundary known as the termination shock. The heliopause, which denotes the boundary between our solar system and interstellar space, is believed to be quite distant. Initially, some speculated that it was as close as Jupiter, but more accurate calculations conducted in 1993 placed it at approximately 25 times the distance from Earth to the Sun, equivalent to 1 astronomical unit, AU. Voyager 1 reached this boundary roughly 2 decades after these calculations, detecting an increase in plasma density. Voyager 2, on the other hand, reached the edge of interstellar space in 2018, only to find that the magnetic field remained unchanged. This discovery was quite unexpected, as scientific theories had predicted fluctuations tied to the Sun's 11-year cycle. Despite the solar wind being at its strongest during Voyager 2's arrival, it contradicted all predictions. With the actual data provided by the Voyager probes, scientists are now refining their models to better understand how the heliosphere interacts with interstellar space. In simpler terms, our Sun has left behind a scorching ionized region and entered a partially ionized section of the galaxy. This fiery zone likely formed when ancient stars nearby exploded in supernovae, heating the surrounding space and affecting nearby atoms. It can be likened to a bustling seaside with swirling waves and water. The area near the heliopause, known as the lively region, showcases chaotic magnetic fields that twist and turn in unexpected ways, deviating from the smooth patterns initially envisioned. There's more. The Voyagers have uncovered a dynamic environment filled with countless small changes, although they have not observed any significant differences in magnetic fields on a larger scale. Eventually, these spacecraft will venture beyond this turbulent region and encounter the pure magnetic field of interstellar space. As we bid farewell to these extraordinary probes, it is crucial to acknowledge that both Voyager spacecraft are still operational, thanks to a system that converts heat from plutonium's decay into electricity. However, their power output diminishes by approximately 4 watts each year, posing a challenge for the mission team. While it remains captivating to witness the Voyagers continue their odyssey, the time will inevitably come when we must bid them farewell. Nonetheless, the probes will persevere in their quest for discovery, even if they lose contact with us. Voyager 1 is currently set to reach Proxima Centauri, our neighboring star, in an incredible 16,700 years, while Voyager 2 will arrive around 3,600 years later. After that, they will continue their journey through the galaxy for countless eons, long after our Sun has faded and the heliosphere has vanished. All of this is done in the name of exploring the universe we call home, a mission that seems to have no definite end. While the Voyagers may still be out there somewhere, their fate remains unknown. There is a chance that they might send a final message along the way, although not through radio signals, and it won't be meant for us humans. Is there a probability that the Earth might not exist when the final signals come? the puzzling sound from out of space. Stella Cooch, a space student at Cornell University, made a remarkable discovery when Voyager 1 detected an unusual humming noise originating from outside our solar system. Alongside her team, they stumbled upon this peculiar sound while analyzing the data from Voyager's plasma wave system, which measures the electron count in space. Despite the soft and repetitive nature of the hum, scientists remain perplexed by its existence. This enigmatic phenomenon holds the potential to provide valuable insights into the workings of space beyond our solar system and its interaction with the surrounding sun's vicinity. The humming sound may offer a deeper understanding of how the sun disturbs the gas present in space. Voyager 1 has been instrumental in expanding our knowledge of space. However, it has recently presented some challenges for NASA. The part of the spacecraft responsible for controlling its movements and its large antenna are not transmitting accurate information, despite appearing to be functioning properly. This issue has not caused the spacecraft to malfunction or deviate from its intended course. The team overseeing Voyager 1 is diligently working to identify the source of the data discrepancy and implement a solution. Suzanne Dodd, who heads the Voyager 1 management team, is optimistic that they will resolve the issue. The spacecraft, nearly 45 years old, surpasses the typical lifespan of electronic devices and operates in an environment for which it was not originally designed. Despite these obstacles, the team remains committed to continuing Voyager 1's exploration of space. Interestingly, the Voyager probes utilize a unique technology, an ancient 8-track tape system, reminiscent of the technology used in the 1970s. It is remarkable to consider that these probes still rely on this outdated technology, underscoring the ingenuity of the mission planners. They ensured that these aged tapes remained functional even after many years. The choice of 8-track tapes may seem odd, but during the early days of space exploration, the digital storage methods we now rely on were still in their infancy. Engineers required a durable and dependable means to store the valuable data gathered by the Voyager probes, and surprisingly, those old 8-track tapes proved to be the ideal solution. What is even more intriguing is the significant scientific data stored on these tapes, essential information about planets, moons, and the vast expanse of space among the stars. These tapes hold the key to unraveling some of the universe's most profound mysteries, rendering them incredibly valuable and significant. As Voyager 1 traversed the silent expanse, its sensors detected an unexpected and faint humming noise that seemed to emanate from the very fabric of space itself. This peculiar phenomenon left NASA scientists perplexed, as they pondered whether it could be a manifestation of a cosmic anomaly or a message from a distant civilization. While grappling with this enigma, Voyager 1 made yet another astonishing revelation. Its cameras captured images of a vast swirling cloud of gas and dust spanning millions of miles. Continuing its journey, Voyager 1 left behind a trail of unanswered questions and awe-inspiring wonder. However, a terrifying discovery prompted the spacecraft to abruptly change its course and head back toward Earth, leaving astronomers to contemplate the countless mysteries that lie beyond the stars. Share your thoughts on this mysterious revelation in the comments below. Meanwhile, the excitement is palpable as Voyager's twin probes bid farewell. Approaching a significant milestone in their journey, they are leaving behind the challenging regions of the outer solar system and venturing into the pristine expanse of the interstellar magnetic field. Yet, bidding farewell to these pioneering explorers will undoubtedly evoke emotions, as concluding any remarkable voyage is always accompanied by a tinge of sadness. Voyager 1 has 4 power sources that have endured for a significant period due to a unique feature. It converts the heat generated by decaying plutonium into electricity. In an astonishing 16,700 years, Voyager 1 will pass by Proxima Centauri, the star closest to us. Voyager 2 will also accomplish this feat, but it will take an additional 3,600 years. These resilient explorers will continue traversing the galaxy for millions of years, even after our sun perishes and the heliosphere vanishes. Even in their silence, these spacecraft may carry a final message. They contain 2 antiquated copper records encased in gold and sealed in aluminum. These records contain sounds and images that depict life on Earth. Was it kept there in case an alien gets a hold of the probes? Probably. Meanwhile, the Voyager spacecraft, as silent messengers from Earth, continue to explore the boundless space between stars, carrying our story and our dreams of connecting with others out there. Nick Oberg, together with a colleague, conducted numerous simulations to track the trajectories of the Voyager spacecraft and their encounters with dust clouds. They also simulated the potential damage that the golden records might face during their journeys. This research also involved considering the possibility that the gravity of these clouds could alter the spacecraft's paths. These clouds possess an immense concentration of mass in a single area. Voyager 2 currently possesses 5 operational instruments. The engraved sides of both golden records are securely protected against the spacecraft bodies, increasing the likelihood of their preservation. However, the outer surface of Voyager 1's record is more susceptible to erosion as time passes. Conversely, the information on Voyager 2's record is more prone to becoming unreadable. This is due to the unpredictable and chaotic nature of Voyager 2's orbit, making it difficult to accurately predict the environment it will encounter. Despite these challenges, it is anticipated that the Milky Way will collide with the Andromeda Galaxy during this period, resulting in a phase of disorder and uncertainty in the paths of the galaxies. Did you enjoy this video? Please like and comment below. Turn on the notification bell to get notifications for videos like this.